Now, one more type of friction was rolling friction, right? See, rolling friction, look at this example. So, I have this wonder tape, okay, and I have this marker. Now, what we'll do, I'll take the marker, okay, I'll just incline. See, it moves. Rolling friction. Why? Because see, at that point of contact, see, when I keep this, only that part of the area is in contact with the surface, right? So, it starts moving, it starts rolling basically. Now what I'll do, I'll take these two and I'll put both of them in an inclined plane. Let's see which one will move faster. Which one you think? Keep one answer, either this marker or the wonder tape. Keep any one in your mind. Alright, so you got your answer? Let's see. So I'm keeping this one and I'm keeping this one. See, same angle. So if I leave, so which one moved faster? This one moved faster compared to this. Now one more thing I'll do. Same these two objects itself, but with more inclination. Now we'll see which one moves faster. See, both of them, I left both of them at the same time. Now what happened? This one moved faster compared to this. Right? Now what observation can you conclude from these two experiments? When with a smaller inclination, the mass which was less, that moved in the beginning, and mass which was higher, that was actually stationary. The stationary meaning it was not stationary, it moved a little slower, correct? Now why that happens? Because of static friction. Remember, static friction and inertia, these two plays a very important part. That rolling friction. Now see, same rolling friction, what I'll do, I'll take the same example, I'll take this, okay, I'm keeping it like this. I'll do a little bit of inclination. See, it moves so easily. See, only so much of inclination. Look at the angle. It's nothing. It's like less than 10 degrees. Now, what I'll do, instead of keeping it like this, I'll keep it like this. Now, if I move by 10 degrees, is it moving? No. Is it moving? No. Look at the angle. It's more than 15-20 degrees. Now, no, more than like 30 degrees, no, 20 degrees something, about 30 degrees, and it stopped again in between. I don't know why, maybe because of some friction. See, I incline more, about 40 degrees. Now if I keep this, it will move. Meaning, even with 10 degree, or not even 10 degree, like 5 degrees, rolling will happen, but not the sliding friction, correct? That's why we say, rolling friction is about 100 to 1000 times lesser compared to sliding friction. Okay, sliding friction, which is very important. Now, when it comes to sliding friction, see, I am keeping an object. During sliding, two important forces act on the body. One is the weight, one is the friction. Okay, so friction is actually this way. This is where it's the force is there, correct? Two forces. Weight, which is acting downwards, friction, which is acting like this. Okay. Now see, okay, let's assume that the angle of elevation is so much, then obviously it will quickly fall. So let's try to keep it maybe somewhere till here. Look at this angle. This angle is theta. Now weight is downwards, correct? So weight is basically like this. Weight is downwards. Now resolve this into vectors. Remember resolving of vectors? So weight is what? mg is the weight. Correct? See here, if I am keeping the inclination, this is your angle theta. I am keeping the weight like this. Now look at it. Even this is also angle theta. Right? This is also angle theta. Now if you resolve it, you will get mg cos theta downwards, mg sin theta in the direction of force. So remember, whenever you have any problem relating to sliding, your weight becomes, or the normal force, because see, normal is like this, right? Normal. So normal becomes mg cos theta, and your force, okay, the frictional force, that becomes mg sin theta. Okay, so resolving of vectors comes into picture. Alright, so this is for sliding friction. Rolling friction, all of you understood? It's just you take an object, see, lesser the area of contact, correct? That's why it rolls easily. Understood? Alright, so this is rolling friction, sliding friction. So this sums up the whole friction chapter. So the previous experiment was static friction, kinetic friction, and we proved how static friction is more compared to kinetic friction, and rolling friction, how rolling friction is lesser compared to those two frictions. Fair enough?